People are cutting inter-array cables between wind farm pylons. This is happening. They don't know how, they don't know when. When you're sending something to Mars, you best be sure that it can survive without any human intervention. Sending stuff out to sea is almost the same as sending something out into space. It's very difficult to send someone or something out there for very long periods of time. The ocean has about 30 times the carbon capture potential compared to the same area on land. If we compare, let's say, kelp forests in the seas versus trees on land, we can leverage what we have today to reach that future, but we cannot just design for something that doesn't exist.
Hey, Patricia.
Hi, Antonin. Thank you for having me.
So I'm really excited about this conversation. Your transition from space to the ocean is fascinating. So you told me when we were preparing this conversation that you had an early passion for space. You were trained as an engineer. You went through NASA, and you're actually now building a startup in the ocean space.
Yeah.
So how did you move from studying the space to researching the ocean?
Yeah, so try to keep it short as much as I can, but I was very much an aerospace nerd as a kid. There was no doubt about it. I went to study aerospace engineering at TU Delft in the Netherlands. It was a minor program in Singapore where I got more into, let's say, the climate robotics topics that definitely motivated me to shift a little bit away from the aerospace industry. On top of, for instance, getting stuck in a forest fire myself and wanted to kind of explore aerospace solution in that space a little bit more. And so, I went to study robotics at ETH Zurich. I worked on a variety of scientific applications. I sort of fulfilled my dream at NASA JPL, working on robotic balloons for Venus. But still, deep down, I wanted to have, let's say, a more impactful venture following my time at NASA JPL. And specifically, I knew that I wanted to kind of take the biggest ownership for it as well. And that's what motivated me to shift more towards entrepreneurship, right? So that was kind of the shifting point.
And that's where you join Entrepreneur First?
Exactly. And so at the time, I was trying to think about, do I want to do this on my own? What co-founders could I work with? And the EF opportunity came up, EF being Entrepreneurs First. And so joined Entrepreneurs First. I was like, why not? Let's try it. And pretty early on, I met Jean, my co-founder, who's awesome, by the way. Huge shout out to Jean. And he came from a background of deep tech climate VC. I obviously had a background in robotic systems in, let's say, extreme environments. And we started looking a bit at opportunities together, and we slowly narrowed it down to the ocean, right? And so what was the starting point there, specifically from a climate carbon capture perspective? If we think about restoring and planting kelp forests in the ocean, it has 30 times the carbon capture potential to trees on the same area on land, right? It's just that planting trees and quantifying that is still quite a bit easier than doing that at scale in the seas. So that was the shifting point for us, and when we started looking deeper into the ocean space, and it's kind of how we got to where we are today.
What are the challenges and what are the solutions that the ocean could help solving?
Yeah, absolutely. So the way I like to think about this is I like to think about sort of four main pillars that reflect kind of some of the challenges that we have in our society that lie in the ocean, right? And so the first one is going to be clean energy, for sure. It's a prevalent topic, and it's actually also the market that we're going more into now, but I'll get into it in a second. The second one is just a general, let's say, climate crisis. So that's kind of how Bubble also started, with this idea of restoration in the ocean, capturing and storing carbon and actually measuring the effects of that, because the ocean has about 30 times the carbon capture potential compared to the same area on land. If we compare, let's say, kelp forests in the seas versus trees on land, which are somewhat easier to plant and measure the impact of than kelp forests in the sea. So that's the second pillar, the climate crisis. The third pillar is for sure food security. I think that's another really big one today. So from things like more sustainable aquaculture and monitoring how that develops to actually discovering new forms of food or even planting new forms of food. So I mentioned the kelp forests before, which are, really beneficial when it comes to carbon capture. We can upcycle those. I mean, and create lots of kind of high nutrient foods that we should, get people on board to like at some point, if we cook them well, I guess. That's the third pillar. So food security, really big one. And also just this whole idea of discovering new forms of life and food and so on that we can even leverage in, medicine down the line. We've had a few talks around those topics. So like kind of the discovery aspect is really exciting. There's the third pillar. And the final and fourth pillar is kind of the, the gray cloud that's been hanging over us over the last few years. And that is, of course, security. And, security of all the pillars before, plus a few other things. So security in offshore assets. I was at an offshore energy conference literally yesterday. We discussed this a lot. So, all of the gas pipelines that are coming into shore, that intersect between different geographies, kind of monitoring those, understanding where failures happen and why, kind of having this little sentinel 24/7 telling you what's going on there almost on a permanent basis. We learned about the data cables, the super long data cables in the Baltic that has been, let's say, an overarching topic that we keep hearing again and again about. And, it's very difficult to send someone or something out there for very long periods of time in order to kind of understand what's going on and be able to report back in case they notice something. At least in a scalable way. It's just not possible without the use of robotic systems, which I'll get into shortly. And then, of course, things like ports, right? Ports, harbors, marinas, sabotage, large boats that are, traversing the oceans with various kinds of goods and all of those logistics. That's a really, really strong topic today as well. So let's say port and logistics security.
For the ocean to fulfill its potential, you actually need to know what is happening in there and in a scalable way. So tell us about the innovation behind Bubble Robotics and how you're trying to solve this.
On one side, we are strongly trying to reduce the costs of operating out at sea because sending stuff out to sea is almost the same as sending something out into space, right? So we're trying to reduce that by having unmanned, fully unmanned, initially remotely operated, down the line fully autonomous systems that we send out there that are much smaller and that are much lower cost, right? On one side, and two, that can gather this type of data 24/7 across very large areas. If we need, higher resolution in one specific point, we can autonomously moor and stay out there for long periods of time, and so on. So yeah, that's sort of the value proposition that Bubble brings.
So when did you guys start playing with that idea, and how did the pitch evolve since you met Jean?
Yeah, so maybe just to bounce back on that, I mentioned, I guess, listeners of this will have seen what we're building, right? Or will have seen the website, but just to reiterate on it. So right now we are building a movable docking station. Looks kind of like a boat, is kind of a boat. Actually, a big part of the reason why it's not like a catamaran in the end, but a boat is because we want it to be self-righting, so to withstand really harsh sea conditions, to bounce back up, that can depart from a port, that houses a baby underwater drone that can be deployed on demand, initially tethered, and down the line also we're looking at fully untethered system, that can perform up-close asset inspection, come back, stay there, and recharge, whilst the little boat dock system itself can still collect other forms of data on demand all the time, right? And the idea is also that we can self-anchor and moor out there at a later stage in order to stay there for 6 to 12 months at a time with ideally minimal to no human intervention, right? And that is the goal. And just to give you a parallel, one of the things that we always say is that we've designed such systems for the space industry, right? When you're sending something to Mars, you best be sure that it can survive years, maybe not years, but you want it to survive at least a year or so usually, collecting this data all the time without any human intervention, right? And that's been possible. So why are we not transferring similar technologies to the ocean where we can actually do it, we can actually intervene a little bit more still, right? But there's that kind of parallel there. So that's actually what we're building. And the vision is that we can become the sort of CubeSats for the seas. So this constellation of these tiny robot dock boats, for sure it is still directly linked to impact and just the reality of the world we live in, right? We cannot live in a utopic or fancy future. We can leverage what we have today to reach that future, but we cannot just design for something that doesn't exist. Not right now, at least.
So what is the main pain point of your early clients?
Yeah. Two main pain points of our early clients. Early clients, I would say, are offshore energy, specifically offshore wind. Pain point one, boats consume too much fuel. People are way too expensive. And their value add, like their added value is sometimes very little because let's say for one person doing an operation, you just need 3 to look at that person just for safety out at sea.
And there are risks associated.
And risks, and all the associated risks, which also means that when they're performing these inspection tasks, and by the way, I'm using the word inspection very generically. There's a lot of details that are associated. It's not just like, a camera, blah, 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 I go back. No, although apparently I learned yesterday that in some parts of Northwestern Europe, that's what's being done. But it's also, let's say, strongly looking at the scour protection system, looking up close at the cables, understanding where they're buried, where they're unburied, and so on and so forth. So that's a whole pillar. So
the problem is not only that it's done by humans, but that it's also not done so well sometimes?
In some parts, but that's governmentally implied. So if they can have someone check a box and it satisfies the governments, they'll maybe be okay with it. But what we see is happening, so that's the main reason, as I said, so the cost of everything, the increased governmental pressure for, doing this more sustainably and so on and so forth. The other thing is, because the costs are so high, people are only looking at 10, 20, at most 25% a year in their asset. So what has happened in the last 10 years is that they've had really unexpected failures. Like this idea of, designing well or over-designing is good enough, it's absolutely not good enough. I spoke to a service provider yesterday again who specifically told me this, right? And so they have huge interest to have the sort of loitering system that can just do things on demand and continuously gather data, on top of the increased pressure of doing more biodiversity and environmental monitoring in the area as well. So that is more specifically to this first customer, right? This first initial beachhead, I would say. And finally, just to complement that, plus security. So the security thing is not just for ports. People are cutting inter-array cables between wind farm pylons. This is happening. They don't know how, they don't know when. So, that's, I would say, the next thing.
You mentioned security. What do you actually mean by that? And what is happening in the ocean that is deeply concerning right now?
Yeah, so there's a general concern specifically in the European space that a lot of energy assets with their interconnecting pipelines and cables, and on top of energy also data cables, are being increasingly sabotaged or attacked by external parties, similar to what we saw in Germany about 3 years ago. And so it's very hard to tell, especially in like an underwater space, which is deep, where it's very easy to be incognito, where it's very easy to not want to operate as a human. It's very hard to tell when and how these things are happening or what the source is, right? So that you can actually have a better conversation on, is this a failure due to our own system or is this a failure due to external sabotage? And this is huge. So just yesterday, I was talking to a port entity at this offshore wind conference, and it's a very strategic port in the European space because they have renewable energy assets 12 miles out from port, and they also have gas pipelines, 4 different gas pipelines coming into their port, right? And they were very much, bullish on the security implications that this has and on novel systems that can be deployed from their own port to be able to monitor these in a more cost-effective and a more efficient way. So we've been having conversations with quite a lot of officials throughout Europe, a lot of defense interests, specifically also in France, for the type of work that we are doing right now. And why it is, what you mentioned before, why it is critical to sustaining the impact. Because if you're just killing off, cables when in an offshore wind farm, well, they're not generating any production. So sad. Yeah.
And how would Bubble Robotics solve this concretely?
Well, we're like little sentinels of the seas. So we're fully self-powered with renewable energy, and we can just loiter around using a variety of sensors, which are modular. So depending on the customer, we can place, additional sensors more tailored to specific applications that can detect if anything is happening, that can deploy things underwater to check if we feel like, oh, maybe there's like a 2% chance there's a threat, right? Who's going to go? No one's going to mobilize a crew, overnight to check up close and realize, c'était rien, like it was nothing. But there we can be like, well, we'll just quickly unravel our ROV or whatever, AUV, depending on our, the version of our system down the line and do a double check. And, maybe we realize, oh, it was fine. Nothing happened. False alarm. But the cost of doing that is like incrementally minimal, right? And so over time, that compounds, which means that the probability of actually, reliably detecting these threats grows exponentially, right? If you have these kind of loitering systems. And you mentioned space. That's actually exactly when we can draw a parallel to space, right? And have this like constant monitoring of our environment that's like sort of independent of everything else or anyone else.
And maybe those who threaten to sabotage our facilities will think twice if this system is in place.
If they know about the system. Exactly, they'll think twice. So, yeah, and I mean, these things can evolve, right? I mean, and Bubble is an ongoing technological development, right? So maybe we'll become invisible to these players, and then we also have to develop our technology to match up to them as well. But, baby steps. But the disincentive is really important.
This is huge for European security. Have you already had like conversations with public officials at a very high level?
At a very high level, yes. So Jean, my co-founder and CEO, is now very much in touch with high-ranking officials in the French defense to discuss the bubble solution.
It really feels like every other month you're identifying a new problem that your robots could solve.
Which is great in some ways, but we are also trying to stay somewhat focused, right? And we are building the versions of the system, full system, incrementally. We have a V1, V2, V3 targeted for like nearshore, medium shore, and offshore assets. So just for context, V1 is like a fully stationary system on the docking side. V2 is like emergency return. V3 is like full boat system. And our initial target market for de-risk in the technology is any kind of nearshore inland assets as well. So from lake applications to ports, we have a first pilot in the port of Barcelona coming up in January already. And down the line, our next market is going to be offshore energy, specifically offshore wind, both on the infrastructure, but also environmental and biodiversity monitoring. Because we want to gather these very large data sets that we can then leverage for this quantification of biodiversity or carbon credits down the line, right, to increase our understanding of the ocean. And I think at Bubble, and I really want to stress on this, we had a very big scientific incentive to start with. And it is something that we're trying to craft in parallel as much as possible, especially because of our initial vision of Jean and I, which was to kind of assist in this whole restoration and carbon capture in the ocean. It's just, it is not necessarily the easiest market right now. And also in terms of the technology that's required to do manipulation and tasks and things in the seas without supervision, the leap is much bigger than actually acquiring experience using more like monitoring, data acquisition tasks without any humans in the loop, which is already a big enough challenge that we can leverage the expertise from to perform all of that more complex stuff down the line. And that is sort of how we envision the development of Bubble.
So what are the similar characteristics between space and the ocean?
Sure.
And how do you explain that we are only now spending more time and resources studying the ocean, while we learn so much about space already?
Yeah, absolutely. So a few things there, I would say. Space has a lot of different colors, right? A lot of different orbital altitudes, literally. And so one true parallel for sure is sort of the harshness of the environment, right? I think that's the first parallel with space, and this varies a lot. If you think of something as a vacuum, right? So, where satellites go around, where satellites orbit, you could argue that it's even less intense than the ocean space, right, or underneath the water. If you think of something as like outer planetary exploration, like for instance the Venus environment, which is what I worked in, you could argue that it's equally harsh to what we find in the ocean today, especially as we go deeper and deeper and deeper. So that's the first thing. The second parallel is for sure the accessibility, right? So we know that a lot of space initiatives today are all about, how can we send stuff out there in a reliable, somewhat unmanned way at low cost, because we can't get there all the time. The ocean, a little less, but not much different, right? And that's actually one of the challenges that we're addressing with Bubble. So that's the second parallel. And the third parallel, I would say, is everything related to, comms, navigation, localization, GPS-denied environments, making things work robustly for long periods of time without human intervention. So I would say these are the main parallels. And to answer your other question on why we haven't explored as much of the ocean space compared to the space, it's a space world today. I think it comes down to history and the developments that we've had in each, right? So, there's always been a fascination with like space exploration, what's out there beyond the stars. At the same time, there was always the political movement in the 60s with the space race, right? The race to the moon, that's another reason. And at the same time, we started noticing, all the benefits that we can have by deploying constellations of systems in space, from, Earth monitoring at scale, monitoring the evolution of certain things such as, mountains or glaciers and so on, to comms, navigation, like a 5G, GPS, all of that stuff, right? And I think space is so valuable when it comes to all our daily lives as opposed to, let's say, only strategic stuff. We now see the same shift in the ocean, right? So we have all of these important pillars, from clean energy, food security, the climate crisis, and also national security, which are becoming more and more prevalent and strategic in the last few years. So that's why I think we have the shift today.
Are some companies who specialize in building robotics for space, are they looking at the ocean as also a business opportunity?
I would say that companies that are specializing in space robotics. So first of all, what are space robotics? Because you can build robots to, do tasks on the International Space Station or decommission the International Space Station. You can build CubeSats, or you can build like Mars, moon robots. I think in terms of, let's say, CubeSats and new like satellite constellations, they have a lot of parallels because they can do a lot of high-level ocean monitoring. But in terms of other applications, I think people will tend to focus on the space environment for now before shifting to anything in the ocean, just because the development timeline, cycles, customers are very different. What we do see, I would say, is vice versa. So there are companies who are developing robots for a variety of applications on land. A famous one is mining, right? Which are saying that we can transfer a lot of this technology to the outer planetary world. So that is definitely happening, I would say. But starting with space doesn't necessarily mean you'll go in the ocean.
Okay.
We might get some talent drain between the two.
Do you already see this? Like,
yeah.
where are you hiring?
Who are we hiring?
Yeah, who and where? Like,
yeah.
What is the background of the talents you're hiring?
Totally. So we've hired, I would say, almost exclusively from my near network, because obviously so far we've just hired technical people. We're now looking for, shout out, founder's associate, because Jean is drowning. But we've only hired technical people, predominantly from my network. So we have a senior systems lead who is a postdoc in underwater robotics and who spent 3 years at NASA, the same center that I was in. That's a connection from one other guy I met there at NASA, who's also absolutely brilliant. And he's our systems lead. So that's one profile, design systems lead. We have a autonomy lead who I worked with very closely at ETH, actually. So not from the space world, but from the GPS-denied environment robotics world, specifically on quadrupeds. So he's our autonomy lead. And we have one mechanical engineer who's previously worked a lot on space stuff as well. Another connection of mine from JPL. And one other autonomy engineer right now, one autonomy data person, actually. Also connection of mine from ETH. So these are the profiles that we're hiring. And we're about to make an offer to an electrical engineer to join our team.
And what gets everyone excited about? Like, is it the mission or?
Totally. For sure, the mission, but it's a bit of a mix. I think people love to work on like super complex, cool robotic things, but they also see the upside of the application at Bubble, right? So the huge impact that you can have on both environment, renewable energy, sustainability, and so on and so forth. Because what makes us, like, we're not only a technical challenge, right? But we also have a big strategic challenge. I mean, we discussed that already. Like, we're not just selling robots. We might, first of all, we're selling a service. Yes, we might sell to, let's say, less tech-savvy people. I don't know, maybe for small marina inspections, example. But we're selling to huge technically savvy players. So the way we have our sales cycles, the way we need to develop our technology, but also in terms of the impact that we can have is very different to something like, I don't know, manipulation robotics for house tasks, right? And I think that's what also makes it exciting in some way. It's like, man, if we can get in on this, we can really get some crazy insights on how this world actually works, right? And how like the general energy economy functions and so on and so forth. So I think that's what also gets them pretty excited.
If Bubble is successful in 2030 or 2035, we'll do it again. If Bubble ends up being successful in, let's say, 5 years from now, 8, 10 years from now, what will we know about the ocean that we don't know already?
We will potentially discover new forms of life, right? Unknown species in the ocean. We will actually be able to quantify the carbon capture potential of the ocean and actually be able to do that without hypothetically saying we can do that. We'll probably be able to finally harness new forms of energy from the ocean, right? So there's a lot of initiatives now for things like wave power, right? And it's like how to harness basically storms out at sea to be able to leverage that in the clean energy transition. And I think Bubble can also be a facilitator for that when it comes to doing stuff out there, gathering data, monitoring, increasing our understanding. So I think that's something really cool. And, you know, discovering new lives in the ocean can also give us a lot of insights into how we function as humans. I mean, the abyss is such a dark place, both literally and figuratively. Like, we don't know what's out there. We don't know what can tell us about, that can tell us about, I don't know, like human cells and how they replicate and how that affects certain conditions that we have. So there's a big initiative. There's actually a big part of the reason why people went to like do crazy space stuff. So outer planetary exploration in space, science in space, because we can learn so much about how we function. So that's our vision. That's what we're excited about.
What do you think is the most interesting regarding technical challenges? Because I'm not so familiar with it, to be honest. So
yeah,
how could I lead you?
Yeah, I think there's a few technical challenges. I think the first one is how do you do things lower cost and reliably? How do you navigate close to strategic assets underwater, you know, deploy a variety of sensors underwater reliably? That's hard. In GPS-denied environments where you have like very minimal acoustic communication. We're specifically working on docking, so retrieval of these underwater systems in harsh environments, harsh waters, high sea states. We're operating a lot in the North Sea, which is horrible. That's another one.
Do you already have a patent?
We filed a patent on the current design.
And what is what is the first technical challenge that you solved in a way, or that you?
Yeah, so we're solving two technical challenges. So one is like enhanced lower cost underwater autonomy.
But what is the one that you kind of already solved? Like, what is when you're pitching funds, you say, look, where are you convincing? When you pitch funds, they feel like, oh, okay, this is already working, we can trust them.
Nothing, to be honest.
Yeah,
like,
no,
I got to be really
yeah,
honest
yeah.
with you.
No, it's okay.
I think the coolest part is like the whole housing of the system and the docking and undocking. So I think that's a really, really important one. Like, there's few of us who actually think about how we marry the mothership with the underwater system and how we can transfer that to a variety of underwater systems. That affects, the weight of the thing, the buoyancy, how easy it is to kind of flip back if something happens. Yeah, there's people like adding it on to USVs, but there's no one thing about like, okay, how does actually marry? How do we marry that well?
You did your master thesis at NASA. What was the exact topic of your thesis?
Yeah. So the exact title was Model Predictive Control for Robotic Balloons. So literally lighter than air buoyant structures on Venus. So for persistent monitoring of the Venus atmosphere, right? So over months, right? Similar to, the Vega missions that were sent to Venus by the Russians. There's like new iterations on those. So that's what I worked on at JPL, and let's say an optimal control framework.
At NASA? You worked
at NASA. At NASA.
For 1 year?
For 10 months. Almost a year.
And how does this research apply to what you're doing now?
Yeah, so there's a bunch of like parallels, which is kind of fun. The first one is fundamentally related to buoyancy. Actually, it's very funny. Like the way balloons fly, like hot air balloons, they're lighter than air structures, airships. They work with the same buoyancy principles as things in the ocean do, which is kind of funny. So that's the first parallel. It's pretty cool. The second one is everything to do with GPS denied environments, right? I think there's a lot of parallels there to the underwater systems that we deploy, and yeah, sort of the harshness, the reliability, right? I think that's another big parallel. So.
And when did you realize that the technical problems that your innovation is trying to solve were actually reachable? Like,
Yeah. I think there's multiple layers there as well. I think when you start building, especially in the aerospace world, you kind of look at what's already been done before, right? And it's like, okay, boats like exist, right? And like solar power exists, and underwater drones that stay out there for years, specifically gliders or up to a year, exist. The way they travel through water is very different to the kind of system that we're deploying. That's a technicality we won't get into now. So you start thinking, okay, how can we combine these systems together in a much more cost-efficient way? And for me, it was, let's say, somewhat clearly possible, right? It's about kind of how do you design it for the specific environment that you operate in. And the second one is also leveraging a lot of the robotic paradigms, because one of the thing is mechanical stuff, right? Which is arguably doable because there's some parallels to what's been done before. And the other one is also like robotic autonomy, the software stuff. So having systems that are much smaller scale, having, let's say, embodied AI on much smaller systems, has been an ongoing shift in robotics in the last 5 years and can be clearly also now applied to the ocean space in an integration way. So yeah, that's kind of when I thought that it doesn't mean it's easy. So it's one thing to have something kind of work in separate ways or once versus have something work reliably for long-term out at sea for 6 months, have something be scaled down, be compact, have something work with a variety of different systems, sensors. Like, people should not underestimate the challenges of integration in robotics. It's still hard, but it's doable. We're not reinventing any huge wheel. We're not discovering something crazy from a purely robotics perspective.
And what is the first milestone from a technical perspective for what you're trying to build?
Yeah, so we have a so-called V1 of our system. And V1 in our system is not the moving thing, but it's the stationary thing. And the stationary thing can de-risk a lot of things, from the docking and undocking of the underwater system that we pair with it, from the power and energy and infrastructure charging the underwater system, communications, showing that we fundamentally don't sink, showing that we can stay in saltwater conditions for a very long period of time. This V1 will be deployed by April next year. So that is the first technical milestone that we're trying to reach. We already have a pilot coming up in January, but that is solely with the underwater system, the underwater drone, right? So the one that we deploy from the mothership to do kind of close-up inspection in the port of Barcelona. And there we try to de-risk a lot of the core autonomy and underwater localization aspects of our system. So yeah, that's V1.
And this should be enough to raise the next round?
We think no, because we are very ambitious for the next round. So in order to meet the next round, we want to have one big fully offshore pilot deployed with a V2 of our system. V2 of our system is V1 with propellers. So V1 that we can show that we can traverse and come back in case of an emergency. So that's basically V2 of the system, and we want to have an offshore pilot with that. And what does it mean, a pilot? It means that maybe we don't come back all the way to port, right? Or maybe we are only 2-3 kilometers away from shore. Maybe we attach to an existing boat for some trial. But we need to show that, hey, our system is small. It's cost effective. It can withstand these harsh environments. Things work, things failed. We acquired this cool data that is really useful to you big pilot first customer, and then we're good to raise the next round. Because to scale this and make it, robust, optimize it, work on, V3.1, 3.2, 3.3, we need to scale the team. That's clear. And for that, we need more money. So yeah.
And how confident are you that you're going to succeed in reaching this first milestone?
I'm pretty confident. Our team is awesome. I'm so hyped about our team. Just this morning, I got like some cool new updates on the data interpretation side. We got like a nice new workstation in the office for our first customer. We're going to show them. We have an update meeting with them next week. We're going to show them. And we already have a lot of our subsystem testing in place. So the whole like kind of docking subsystem, we have almost final design for that we want to now kind of shift from like 3D rapid prototyping to actual being manufactured and trying it with the drone. So I'm pretty confident we can reach V1 and a robust V1. It's about kind of convincing the cool players that they should pilot with us, which Jean is very well taken care of. So yeah, I think we can do it.
And what are the skills you're hiring for within the technical team? Like
coming up, or what we have now?
Well, the hirings you're running now.
Yeah, so we have a lead systems engineer with a postdoc in underwater robotics from both mechanical to autonomy expertise. He's just taking full ownership of the full system design. We then have a autonomy lead, so control, software, data. He's in the team now too. We have a data autonomy engineer too, so working on this kind of first pilot underwater drone aspect. They'll then shift to working on the autonomy of the USV as we shift to version 2. And then we have one awesome mechanical engineer and about to make an offer for an electrical engineer. So, yeah.
And where is the team based?
So most of the R&D right now is in Zurich because that's kind of where a lot of my connections were, and because it's like a really hot robotics place in Europe. It's probably the hottest in Europe right now. But most of our operations is in France. We are now literally kind of as we speak partnering up with the Ifremer in France for a lot of testing and deployment, and down the line kind of co-building certain aspects. And we're looking at kind of doing all of our, once we finish this R&D phase, a lot of our manufacturing, building, further design iterations in France. So that's the plan for now.
And are you partnering with similar organizations like Ifremer? Maybe you can say a few words about Ifremer, what it is, and why is it such a strong partner for you?
Yeah, so Ifremer is a fantastic partner because they are pretty much, they're one of the largest oceanographic research institutes in the world, in Europe, naturally speaking. They've worked extensively on underwater autonomy as well, of much larger systems and very reliably. They have awesome test beds. So just yesterday, we were having a discussion about using their various pool and canal infrastructure early next year to de-risk some of our systems before sending them out into the open sea. They have specific boats that we can use for trials, and we're trying to kind of design these partnerships to apply for public funding here in France in order to push these through.
Is it easy to work with an organization like this? Does it go as fast as you would like?
The short answer is not really, but that's just every organization like this. And we're not only working with Ifremer, we also have some partners in the Nordics because we're applying for these European consortiums. And because Europe is trying to be like more united, you have to show that you have parties in a lot of different countries, right? And yeah, I mean, they on paper just move a bit slower than we do, but that's just how it is. And you just have to plan things in advance, be transparent with them about how ambitious your goals are and kind of get them to move as fast as possible. Like you gotta put the pressure, and they know, like if they're gonna watch this, they know to let's say cater to you as fast as you can, and then get them excited about the project, because if they're not excited about the project, they're not gonna want to move faster for you.
So who are the early customers, and in the long run, who will be your clients, and what business model are you building?
Yeah. So the very quick customers are ports and marinas, and also, let's say, biodiversity or like restoration players that we're in touch with in the ocean space. Even labs in universities, even governmental entities that are trying to do, monitor part of their coastline or do restoration and so on. So these are very quick first customers. Immediate customers after that will be the offshore energy players, right? For both infrastructure inspection and environmental monitoring. And by immediately after, I mean, ideally piloting by next June, right? That's like 6 months from now.
And the business model?
Yeah, exactly. And so for the business model, we're trying to offer everything as a service. Trying is not the right word here. We are offering robotics as a service. We're doing RAS, which means we are owning the assets that we're deploying and fundamentally selling the data, and also upselling on the data, like shifting from, hey, you've seen that this is really great. Now let me show you how this really helps this predictive maintenance model that you've been trying to create, or this digital twin of your asset, right? And there'll always be like things like software updates, plug into a full like data stack that we sell to the customer when they operated with us, right? Because fundamentally we need to interface on a low level with them, because they also have a lot of expertise that we don't have when it comes to actually the type of data that we provide, the way that integrates into their existing workflows. That is super important for us, and something that we're trying to understand from a very early stage. So that's the business model. And sorry, just to finish on that, we're basically trying to offer, so the price point is 1/10 approximately, at least to start with, of what they pay per day to do this now, just to be compliant without all of the additional things that we can do, right? Just to match their current service.
And the data you're going to gather over time will be so valuable for many other actors.
Yeah, for sure. And just to dive in a bit, for sure, such as insurances, that's a really big one. Environmental monitoring agencies, governments as well. So yeah, a lot of other players. And just to say, because sometimes we get the question, I'm asking myself a question that you didn't ask, but whatever. Sometimes we get the question of like, why 1/10 of the price? Like if you're the same or better, just like do the same price, right? Yes and no. You need to start off at a price point that is so freaking competitive that they're like, this is a no-brainer.
Yeah.
Once you show that you're so damn good, I hope that will happen, that we're so good, then you can start saying, now you like it, let's discuss, there's upsells, and more things will come, right? New sensors, more expensive sensors, things like that.
But once they're hooked.
But we need the baseline that matches their expectations at a very competitive point where we can deliver the same quality of service. Because if we can't deliver the same quality of service, no one's really gonna want to shift that easily, right? And so that's why we're trying to get, design partners early on, people, who can vouch for us, champions in the industry that are now pushing for us to get them to co-design with us, which is the most important part. And it's happening.
Okay, we're approaching the end of the conversation. Tell us what Bubble Robotics could look like in 8 to 10 years from now.
Yeah, absolutely. So Jean and I, our vision is to become like the autonomous workforce for the ocean. So leveraging the ocean for discovery, for understanding more about how we as humans kind of live and coexist, for food security, energy security, and also for conservation, all whilst preserving the ocean at the same time. So that is the vision for Bubble Robotics.
Well, thank you. Sounds very cool.
Thank you so much, Antonin, for having me. And yeah, hope you enjoyed.